body is at rest. We know that in order to produce a change in the state of rest of the body, we need to apply force. On applying a certain amount of force, the body can be brought into motion. Now consider that two men apply equal but opposite forces on a body which is at rest. We can see that even though force is being exerted, the body does not undergo any motion. Why is it that the body does not move, even on application of force? Let us see. To answer this question, we need to analyze the different forces acting on the body. Even before the men apply force on the body, there are two forces acting on it. The body experiences a downward force due to the gravitational pull of the earth. This force gives us the weight of the body. The weight of the body is balanced by an equal but opposite reaction force applied by the Earth's surface on the body. Since these two equal but opposite forces cancel each other, the net force acting on the body in the vertical direction is 0. Now, in addition to the upward and downward forces, two additional horizontal forces are applied. Let the force applied by the man on the left be F1 and that applied by the man on the right be F2. Since the forces are equal and opposite in nature, the two forces cancel each other. Thus, the net force acting in the horizontal direction is also 0. Therefore, even though four forces are acting on the body, the net force acting on it is 0. As a consequence, the body remains in the state of rest. Such a body which remains in the state of rest even when it is under the influence of several forces is said to be in static equilibrium. Let us look at some more situations in which we experience static equilibrium. Consider that some boys and girls are playing a game of tug-of-war. In case the forces applied by both the groups are equal and opposite, the net force acting on the rope will be 0. This represents a case of static equilibrium, as there is no net motion even under the influence of forces. Look at the two girls sitting on the seesaw. Assume that the girls are of the same weight and are sitting at the same distance from the fulcrum. In this case, the clockwise moment generated by the weight of one girl is cancelled by the anti-clockwise moment generated by the other. Since the seesaw does not undergo any rotational motion, we can say that it is in the state of static equilibrium. Consider that a car is moving on a highway with a constant velocity of 50 kilometers per hour. Since the velocity is constant, the car undergoes 0 acceleration. Therefore, the net force acting on the car must be equal to 0. Let us look at the different forces acting on the car. The frictional force between the road and the car opposes the motion of